Good morning, students. In the last previous video, we have discussed the heat, work, and internal energy. So, in the last class, we have discussed only the heat and work. Heat transferred by the system is taken as negative. Okay. And heat gained by the system, that is the system when it is gaining the heat is taken as positive, and the system which is losing the heat is taken as negative. Okay. And work done by the system is taken as positive, work done on the system is taken as negative. Okay. So that is all what we have discussed in the last class. And in this class, we are discussing the internal energy. Internal energy. That is same that continuing the last previous topic. Heat, work, and internal energy. Internal energy. Now, what is this internal energy? What is this internal energy? Okay. Internal energy is nothing but the sum of the kinetic energy of all the constant particles and the potential energy of all the constant particles is called the internal energy. Okay. Internal energy is denoted by delta U here. That is the summation of the kinetic energy of the constituent particles plus summation of the potential energy of constituent particles is called the internal energy. So, when we heat any body, its internal energy is going to be changed. Okay. A body which consists of particles, then if we are raising the temperature of that body, the particles start to vibrate and there will be change in the internal energy. Okay. So the internal energy means the sum of the kinetic energy of the constant of all the particles plus the sum of the potential energy of the constant particles of that system is called the internal energy. Now the sign convention for this internal energy, sign convention. So when you have to take positive and when you have to take negative. Okay. Now here, increasing internal energy, is taken as positive. Is taken as positive. If the internal energy of the system increases, then it is taken as positive. Now next, decrease in internal energy. Decrease in internal energy is taken as negative. Is taken as negative. So whenever there is an increase in the internal energy, then it is taken as positive, and whenever there is a decrease in internal energy, it is taken as negative. So this is all about First law of thermodynamics. First law of thermodynamics. Okay. Now, as we discussed, the zeroth law of thermodynamics. Okay. So, what it states that if the temperature of the A system is equal to the temperature of the C system, and if the temperature of the B system is equal to the temperature of the C system, then the temperature of A system is equal to the temperature of B system. As here, A system and C system both are separated by a conducting wall, and B system and C system is also separated by a conducting wall. But the A system and B system both are separated by an adiabatic wall. That means there is no exchange of heat between A and B. So, but because of due to the presence of this the conducting wall between the A and C and B and C, there is a transfer of heat takes place. So, until and unless A and C both are equals and B and C both are equals, and if I remove the adiabatic wall between A and B, then there is no exchange of heat we can see. That means both are attaining the same temperature. And that is what the zeroth law of thermodynamics says. Now, first law of thermodynamics. Okay. Now, say for example, the system is absorbing a Q amount of heat. Now, a system is absorbing the Q amount of heat. Then, here W is the work done by the system. W is the work done by the system, and delta U is the change in the internal energy of the system. Okay. Now, mathematically we can write this first law of thermodynamics as Q is equal to, if any system it absorbs the heat energy, then there will be a work done, and also there will be increase in the internal energy. Okay. So this is mathematically. It is mathematically. Okay. So here Q is the amount of heat absorbed by the system. So once the heat absorbs the system, then there will be some work done takes place, work done by the system or work done on the system takes place, and plus also there will be change in the internal energy of the system. That change, it might be an increase in the internal energy of the system or decrease in the internal energy of the system. So this is what the first law of thermodynamics says. I write the complete statement of this first law of thermodynamics on the board. Just to note down it. So here the statement, it says that it is stated as the energy entering the system, in the form of heat is equal to the sum of the increase or it is the sum of the increase in the internal energy some of the change, so we can write it change in the internal change. It might be increase or decrease here. Internal energy of the system and the heat energy leaving the system in the form of work done by the system on its surrounding is the first law of thermodynamics. The energy entering in the system, here energy is equal to Q. Q is the amount of heat energy which is entering into the system in the form of heat, is equal to the sum of the increase in the or change in the internal energy of the system and the heat energy leaving the system in the form of work done by the system on its surrounding is what the first law of thermodynamics states. Okay, now we can write this equation 1 as here. I am writing, I am just copying this one. This can also be written as we know, Q is equal to W plus delta U. So which can also be written as delta U is equal to Q minus of W. Okay. So this defines the internal energy of the system. So internal energy of the system is the difference between the amount of heat energy absorbed by the system and the work done by the system or on the system is called the internal energy. So once again I am repeating here, internal energy is defined as the difference between the amount of heat absorbed by the system and the work done by the system or on the system is called the internal energy of the system. Now here in this equation 1, here Q and W. Q means amount of heat absorbed, W means work done. Both are taken as positive, negative or also 0. And whereas the internal energy delta U is taken as positive or as well as negative also. So that is all about the first law of thermodynamics. Okay. So here mathematically we can write this first law of thermodynamics as Q is equal to W plus delta U. When any body it absorbs the heat energy, then there will be the work done and also there will be change in the internal energy of the system. Okay, so that is all about the first law of thermodynamics and the internal energy of the system. Internal energy means change in internal energy is equal to the sum of the kinetic energy of the constant particles plus sum of the potential energy of the constant particles. Increase in internal energy is taken as positive, decrease in internal energy is taken as negative. So this is all about in today's class. In the next class we will discuss